guys, sorry I couldn't be there today. Please be good for the sub. Today we're going to talk about the quadratic formula, which I'm hoping sounds familiar from Algebra 1. It's a long formula we'll get to in a second. And we're also going to talk about discriminants. We'll start with that. First of all, we're going to focus on quadratics when they're in that standard form we've done a bunch with the ABC. It's got to equal 0. The discriminant is just a formula using those ABC numbers. It is b squared minus 4 times a times c. The idea with a discriminant is not to help you solve, it's just going to tell you how many and what type of solution you have. So there's an option of having 0, 1, or 2 solutions, and there's real solutions, and we haven't talked about this yet, but there's also imaginary solutions, and we'll get into that a little bit later. Okay, so those three options right here. So if they're quadratic, you plug in your ABC, you have three options. It's either greater than 0, which is just another way of saying a positive number. It can be exactly 0. It can be less than 0, which is a negative number. Okay, so depending on what you get, if you have a positive number, you're going to have 2 real solutions. That is what the majority of our problems have been so far. So like think about when you were factoring, the majority of them had this 2 different answers. And then we also, before Thanksgiving break, did graphing. And when we looked at the graphs, we were looking at the x-intercepts. Remember, solutions is the same thing as x-intercepts, the same thing as roots, is the same thing as zeros. Okay, so it would look something like this, or maybe like this. Okay, so the idea is if you have a positive discriminant, you know the graph has 2 x-intercepts. Not necessarily where they are, just that there are 2 of them. Okay, next option is if it's exactly 0, this is just going to have 1 real solution. So on the graph, that just means that your vertex is also your x-intercept, only touching at that one point. It could be something like this, it could be something like that, but there's 1 x-intercept. Okay, hopefully what makes sense to this is that the discriminant is not telling us everything about the graph. I don't know where the vertex is necessarily. I don't know where the x-intercepts are, just how many there are. Okay. And then the third option is you have a negative discriminant. This is where we're going to have what's called imaginary solutions. You're going to have 2 imaginary solutions. Okay, we will get into that more next week when I get back with what imaginary means and all that. Just for today, no, 2 imaginary. It is another way of saying 0 real, just FYI, but I want you to focus on the fact that it's 2 imaginary. Okay, and then on the graph, that just means that if you have no real solutions, it's never touching the x-axis. It'll be something like that. So those are your 3 options. Let's go ahead and practice real quick with 3 problems. I'm going to scoot this down real quick. Okay, so on the first one, A is the -2, B is the -3, C is 5. So use your formula. We're going to do B squared minus 4 times A times C. Plug in the right numbers. Be really careful with the negatives. All right, B is a -3, and we've done this a bunch, but if you don't put those parentheses around the -3 before you square it, the calculator will not do that math correctly. So you really gotta be careful with the parentheses. A is -2, and C is 5. Okay, go to your calculator, plug it in exactly how you wrote it. Oh, excuse me. So -3 squared minus 4 times -2 times 5. Let me get this a little closer so y'all can see. All right, 49. Okay, now again, I don't care exactly what the number is, just the fact that it is either positive, 0, or negative. So this one is greater than 0, so I'm in that first option. I'm asking for the number and type of solution, so the answer to this one would be 2 real solutions. Okay, so let's practice it 2 more times. Now, the issue with the next 2 problems is that neither of them are exactly in standard form. They don't equal 0 yet. So on the first one, to fix that, I'm going to subtract that 2x. Now it'll equal 0. The issue with this on the left side, though, is if you don't put this in the right order, where we have the x squared, then the x, then the c, the constant number, you're going to get your ABCs confused. So I'm going to put the 6x squared first, the minus 2x next, then the plus 5 equals 0. Okay, So A is 6, B is -2, C is 5. So again, be careful with that -2 when you plug it in. It's got to have parentheses. -4 times A times C. Go to your calculator, plug that in, and if you do it correctly, you should be getting -116. Okay, and again, I don't care what the number is exactly, just the fact that it's less than 0. So I have 2 imaginary solutions. Okay, you can probably guess what the next one's going to be, but let's go ahead and practice. So I need to have this one in standard form again, so I'm going to add the 36 to the left side. I'm going to write it over here to save some space. Okay, so really trying to practice with those negative b's. So again, parentheses, necessary, -4. Now on this one, there is no number in front of x squared, so just a reminder, remember that means there's an understood 1 there, so A in this case is 1, C is 36. Okay, go plug all that in your calculator. Again, if you do it correctly and you have all those parentheses in there, you're going to get 0. Okay, and the fact that it equals exactly 0 means that we're in that second group and we have one real solution. All right, that's it. That's how you find discriminants, and that is what you can decide based on the discriminant. Now, this is not the focus of today. It's just a little building block. Here's what we actually want to focus on, the quadratic formula. Like I said, this is our last way of solving. Okay, so this is a long formula. Some of you might have learned it in Algebra 1 using the Pop Goes the Weasel song, and if you haven't, I recommend looking up YouTube videos for that. It is kind of a fun way to help memorize the formula. So we're still using those ABC numbers. So the first thing is that x equals -b, plus or minus. Remember, we used that sign the other day. It means that you really have 2 different things happening here. One of them has a positive side, one of them has a negative. We're just writing it together to kind of save some space. So plus minus square root b squared minus 4ac, and then all of that, not just the radical, but the entire thing needs to have the line underneath it, so you can divide 2a. Now, the thing underneath the radical should look familiar. It's what we just talked about. That is where the discriminant's coming from. And that's why if you have a negative discriminant, it's meaning imaginary because you can't take the square root of a negative, and we'll get more into that later, but that's where the discriminant's coming from. Okay, so let's practice. On the first one, I really do recommend kind of identifying your ABC before you jump in, and this one has that issue of not being in standard form, so subtract that 4 over before you do anything else. All right, so on this one, A is 2, B is negative, remember, understood 1, C is -4. Be careful with the negatives. Okay, so use your formula. X equals, the formula says -b, and B is also negative, so negative from the formula, and then I am plugging in -1. I really recommend writing out the step where you're plugging everything in and using parentheses and then simplifying. When you do all of it at once, you're going to make mistakes. So negative, plug in B, plus or minus, square root, -1 squared for B squared, -4 times 2 for A, and -4 for C. All right, again, make sure that fraction line goes underneath everything, and then we're doing 2 times 2 for A. All right, now, I will eventually let you plug all of this in as one big fraction, but the issue with that is it might give you decimals, and I don't want decimals today. Okay, I want to leave it in that radical form, which is why we practiced simplifying radicals the other day. So there's 3 different sections here, really. I want you to focus on just simplifying each piece individually. So the first piece is that -1. That's just +1. The bottom's pretty easy too. 2 times 2 is 4. Now on the radical part, if you plug it in with the radical on top in the calculator, that's where the decimal might be coming from. So when you're going to your calculator, I really just want you to plug in the discriminant part of this. So I am not putting in a radical. I'm just doing the -1 squared minus 4 times 2 times, -4. Okay, so again, no square root over it, just the numbers. And I get 33. Okay, so if I go back to this, I still have the square root part, but the discriminant is 33. Now, I'm not asking this, but here's what we could decide from the discriminant. If this is a positive number, go back up here, that means we know there's going to be two real solutions. If you're to graph that equation down there, you should see two x-intercepts. Okay, now how do we proceed from here? I want my answers today to be in simplified, what we call simplified radical form, which basically just means I don't want decimals. Now, what I want you to focus on is the radical piece. So in this case, I have the square root of 33. Think about what we did the other day with all of our perfect squares. Can you think of any factors that multiply into 33, but they are perfect squares? The only numbers that multiply to 33 are 3 and 11. Neither of those are perfect squares, so this is actually as simplified as possible. So this is actually the answer. Now, if you could simplify, you want to simplify, but this one doesn't simplify, so we're done. Remember how we said the discriminant was positive, so we should be having two solutions. The reason it doesn't look like we have two solutions is because of that plus minus. So if I was to write this out, one of my solutions is 1 plus the square root of 33 over 4, and the other solution is the 1 minus the square root of 33 over 4. Okay, but we're writing it together to save space. So that one's done. Number two. It's already in standard form, so we're good. A is 1, B is 6, C is 9. No negatives. Should be a little bit easier. So go to your formula. We got negative. I still recommend plugging everything in parentheses just to be safe. It's a good habit. Plus minus, square root, b squared minus 4 times a times c, fraction over everything, 2 times a. Okay, simplify each piece individually like we did on the previous one. So negative 6 is just negative 6. Okay, again, I'm not going to plug it in the calculator with the radical. I'm just going to do 6 squared minus 4 times 1 times 9. So if you plug that in correctly, you should get 0. 2 times 1 is 2. Now, here is what this means. So think about it. That's the discriminant. Up there top, we said if we had a discriminant that equals 0, we should have one real solution. So if you go look at the graph for number 2 down there, it will have exactly one x-intercept. So when the discriminant equals 0, there's going to only be one solution. Okay, so as we simplify this out, you'll see how that works. Now, what is the square root of 0? 0. 0 times 0 equals 0. So this is really saying negative 6 plus and minus 0. Now, negative 6 plus 0 is negative 6. Negative 6 minus 0, still negative 6. So really this is negative 6 divided by 2. That is why when you have a discriminant of 0, you only have one solution, because that plus minus thing doesn't actually end up happening because 0 doesn't change anything. So the only solution to this one is that x equals negative 6 divided by 2, which is negative 3. Okay? So we had a 2 solution and a 1 solution so far. We're going to do one more. This one does have a kind of a weird format. I did that just for some fun practice. It has to be in standard form, so make sure you distribute. That'll be x squared minus 5x equals negative 4, and then you also have to add that 4 over. So we've got x squared minus 5x plus 4 equals 0. So a is 1, b is negative 5, c is 4. This would be a really great place to pause the video and go ahead and try plugging it in yourself and simplifying out as far as you can. And then you can push play again and see if you got it correct, okay? That's what I would do. Okay, so plug it in. We got negative b, so again, negative, negative 5, plus minus square root b squared minus 4 times a times c, big fraction, all over 2 times a. Again, 3 sections, simplify them separately. Negative, negative is positive 5. Plus minus. If you go plug in just the discriminant, you do, let me get to where you can see, negative 5 squared minus 4 times 1 times 4, I get 9. Okay, so that all thing is 9, and then 2 times 1 is 2. Now, this is where we stopped on the first one, but remember, that was because the square root of 33 couldn't be simplified. The square root of 9 can. That's a perfect square. The square root of 9 is exactly 3. So I can actually keep going on this problem. This is 5 plus or minus 3 over 2. And then since I no longer have any radicals, I can actually split this up and keep going even further. So I'm going to now separate the plus minus. One of these answers is when we do 5 plus 3 over 2, and the other answer is when we have 5 minus 3 over 2. Okay, and so if I simplify these out, 5 plus 3 is 8, 8 over 2 is 4. So one of my solutions is that x equals 4. The other one, 5 minus 3 equals 2, 2 over 2 is 1, so the other solution is that x equals 1. Okay, so that's really the idea. There's lots of different types of problems, so I can't guarantee that they're all going to be exactly like these, but the idea is you're going to have either 2 or 1 solution. I am not going to give you any with the quadratic formula today that give you 2 imaginary, because that's a little bit more complex. We will talk about that next week. So for today, just be aware when you're asked to solve, it will always be either 1 or 2 solutions. It might be still in radical form. And the only example of things I didn't give you was where it was still in radical form, but this could be simplified. So that is an option. So the sub should hand out the worksheet. Give everything a try. The discriminant part at the top, I'm really not expecting a huge amount of issues. The quadratic formula, 6 problems at the bottom, you need to try. It is due Monday, but just know that our warm-up on Monday will be me going over probably 2 of those questions, okay? I will possibly be after school today for tutorials if you want to stop by for maybe 5-10 minutes to ask questions, but it won't be for very long, okay? So please be good. Do as much as you can. Help each other out. There are plenty more videos online for quadratic formula and YouTube videos you can watch, so feel free to keep looking at those, but do your best. Y'all are great. All right, I'll see you guys on Monday. Have a great weekend. Bye.